Okay, so this is going to be the same circuit that we went over in the previous video. In this one, we're not going to do the differential method. We're just going to solve it using the formula x of t is equal to x at time infinity plus x at time 0 minus x at time infinity, both multiplied by e to the negative t minus the initial time, to, over tau. Now, in order to solve for tau, we're going to use tau is equal to the R Thevenin at time infinity divided by the inductance L at time infinity. So we're going to look at the before first in order to solve for I initial, which in this case is the same thing as x initial. So in order to do that, we're going to draw the current around the loop here. So the current's going to enter the positive side of that voltage. So we're going to have positive 12 divided by 6, which is going to give us 2 amps. So now we just have to solve for the current at time infinity. So here, when we minimize this at time infinity and we open the switch, it's going to cut off the source for the 12. So that one is going to be shorted out and that 12 is not going to count. Same with this 6 resistor here. So we're going to be left with the 2 Henry inductor and the 6 ohm resistor. As you can see, there's no source to this, which means that there's no current, especially if this is for an infinite amount of time. The inductor is going to lose all the charge that's in it. So we're going to have the x infinity, or I infinity, is equal to 0 because it's not going to have any charge on it and there's no source. So we can go ahead and plug those in now. So we have x of t is equal to x at infinity, which is 0, plus x initial, which is 2, minus x infinity, which is 0, times e to the negative t. Our initial time is going to be time 0, so we don't have to write that up there, divided by tau. So now we have x of t is equal to 2 e to the negative t divided by tau. In order to solve for tau, we're going to look at the resistance at the final time, at time infinity, and we're going to see what the resistance would look like as looking from the source, which is the inductor source right here. So looking in right here, what is the current where this is a node and this is a node? We can see that is going to be 6 ohms. And our inductor is 2 henries. So what we're left with is 1/3. Whenever we have 1 over tau like we have now, it is just the same thing as 3. So we can rewrite this as 2 e to the negative 3 t, which is what we got last time too. But this is just a lot quicker and easier way of solving it.